What happens if you try to put out the sun with water? It sounds like a ridiculous question, but at some point I genuinely started wondering, is there even enough water in the universe for a star the size of the sun to notice? So I decided not to start small. I created 50 planets made of pure water, each one the size of Earth, and launched them straight into the sun. Honestly, I expected to see something, the sun cooling down, or at least becoming less active. But the exact opposite happened. Even after dozens of impacts, the sun looked like it didn't care at all. When you check the stats, its mass barely changes, like those planets are mosquito bites to it. And then the temperature suddenly starts going up. So instead of extinguishing the sun with water, I actually made it hotter and brighter. And that's the scary part, because we're not talking about a few oceans here. We're talking about 50 entire worlds made of water. And if even that doesn't change anything, then the next question is completely insane. What happens if, instead of 50 Earth-sized water planets, we throw in 50 water planets the size of Jupiter? After the experiment with Earth-sized water worlds, it became obvious that the sun doesn't take those volumes seriously. So this time, I switched to a completely different scale. I created 50 water giants the size of Jupiter, and I spaced them out on purpose so they wouldn't collide with each other on the way in. I wanted this test to be as clean as possible, just to see what the sun actually does when you throw an insane amount of water at it. And almost immediately, you realize how brutal the conditions are here. Long before these planets can even get close to the sun's surface, the radiation and the stream of charged particles start literally boiling their outer layers. The water flashes into vapor, and huge clouds of superheated material form around them, filling the scene with this pale, whitish haze. But the most interesting part is the sun's reaction. Instinctively, you'd think that this much water should cool it down at least a little. I mean, we're basically throwing dozens of Jupiters, made entirely of water, into a star. But the problem is, the sun isn't a fire you can put out. Inside a star, the temperature is so extreme that water can't exist as a liquid, or even as normal steam. The molecules are ripped apart into individual atoms, and hydrogen, which water contains a lot of, is literally the sun's main fuel for fusion. So we get this completely insane situation. Instead of extinguishing the sun, we're basically feeding it more fuel. And you can see it in the sun's stats. After the impacts, the temperature goes even higher, the glow intensifies, and the star starts looking noticeably brighter and hotter than it was at the start. At one point, it even stops looking like a familiar yellow ball and shifts toward a harsher white-blue tone, almost like we're forcing it into a hotter state. Because we just sent 50 Jupiter-sized objects made of water into the sun, and instead of cooling it down, we got a brighter, more aggressive star. So far, everything is going in the exact opposite direction. And if even this amount of water can't really affect the sun, then what would it take to even try to put it out? After the experiment with the water Jupiters, I started wondering where the limit even is, because the whole thing was getting absurd. The more water I threw into the sun, the hotter and brighter it seemed to become. So this time, I raised the stakes for real. Now each water planet has the mass of 20 Jupiters. At that point, this isn't a water world anymore. It's an object that's closer to a failed star than to a planet. And the most beautiful part happens before the impact even begins. Look at their surfaces. They start changing color, and each one does it differently. Stripes, bright zones, weird gradients, almost like national flags painted across these giant boiling worlds. It looks amazing, but the reason is simple and terrifying. With that much mass, the pressure inside becomes extreme. Water stops being water in any normal sense. It shifts into exotic states, layers heat up and compress, and the simulator highlights different regions based on temperature and density. That's why you get that striped, multicolored effect. And then these 50 monsters go straight into the sun. But the strangest part is the sun's reaction. I keep the stats panel open and watch the numbers, and the sun doesn't get heavier. The mass barely increases, and it even drops slightly. The radius doesn't expand either. It actually shrinks by roughly 10%, and the temperature goes completely insane. The panel starts showing hundreds of thousands of Kelvin, and visually, the sun turns harsher, more white-blue, more violent. So water still doesn't extinguish the star. It gets ripped apart into atoms, and here's the irony. It's mostly hydrogen, and hydrogen is literally fuel for a star. On top of that, a lot of the material ends up in ejections and glowing clouds around the sun instead of settling as added mass. And after all of that, I'm left with one question. If even 20 Jupiter water worlds can't put out the sun, then what possibly could? This next experiment sounds completely insane, but what you're about to see looks like the beginning of the end. I took water planets and I didn't just make them big, I made each one 40% the mass of the sun. That's not really a planet anymore, that's almost a star, made out of water. At first, they look pitch black, like dead chunks of matter drifting through space. But then, in less than a minute, something weird happens. They start turning into stars, and the reason is simple and terrifying. With that much mass, the object crushes itself under its own gravity. Pressure skyrockets, the interior heats up violently, and this water planet stops being water in any normal sense. It becomes superheated plasma, so we're literally watching a small star being born out of something that was supposed to put out a star, which means I tried to extinguish the sun with water, and instead I accidentally created new stars. And the moment these newborn stars reach the sun, we get a supernova-like flash, a massive, blinding explosion, and an enormous cloud of ejected material. At that point, the sun is gone, and the solar system is basically finished. If you enjoy insane experiments like this, subscribe and tell me in the comments what experiment I should run next. I'll pick the best ideas for the next video.